More log equation practice. Okay, question 7. I see I have two logs, one on each side, but there's also that term 1 plus 1. What are we going to do? We're going to put our logs on the same side of the equation. Well, this looks like an equation with two logarithms, but we can't use that property 8 because of that 1. We can write these as a single log on the left using the property. Now that we have an equation with a single logarithm, we can change it to exponential form. What base are you going to use? I hope you remembered that when no base is written, we have the common log, base 10. And now we have an equation you can solve. So we need to check our solution of x equals negative 9 over 11. If I substitute it into this argument here, we have 1 minus negative 9 over 11. That's greater than 0. If I substitute it here, we have 1 plus negative 9 over 11, which is also greater than 0. So we can keep this solution. Solve question 8. On the left, you wrote it as a single logarithm with a quotient. You changed it to exponential form. You found x equals 1, and when you substituted it into your arguments, they were always greater than 0. So we had one solution. One final equation for you here. 4 logs. What are you going to do? When you simplified each side into the quotient of 1 log, you quickly ended up with just a rational equation. Since 9 over 2 is equal to 4.5, we can quickly see when we substitute that into our arguments, it will always be greater than 1, and so we have our one solution. Make sure you spend time with these equations before we start looking at other and perhaps more difficult types of equations.